Hey, good to see you again in this universe of bold questions and strange answers. Here, every fact hides a bigger story, and we're about to uncover it. A microburst of color snaps into place. Okay, let's slide straight into today's discovery.
Some inventions are planned. Others change everything by accident. The steam engine wasn't created to power cities. It wasn't meant to run factories. It wasn't designed to start a revolution. It was built for one simple, messy problem: water flooding coal mines. And yet, that humble machine triggered a chain reaction that reshaped transportation, industry, science, economics, and daily life itself. This is the story of how a practical fix rewired civilization. Picture England in the early 1700s. Coal is everything: heating, industry, growth. But the deeper miners dig, the worse the problem becomes. Water floods the shafts. Work stops. Entire operations collapse. Human labor and horse-driven pumps aren't enough. The Industrial Revolution isn't waiting to happen yet. It's stuck underground. And that's where the story begins. Engineers aren't dreaming about transforming humanity. They just want to remove water. Before Newcomen, inventor Thomas Savery had patented a steam-powered pumping device in 1698. It worked, but only in limited conditions, and was prone to failure. Then, in 1712, Thomas Newcomen builds a different kind of machine designed for one job: pump water out of mines using steam. It's loud, massive, inefficient, and revolutionary. Here's how it worked. Steam filled a cylinder at low pressure. Cold water was injected. The steam condensed, a vacuum formed. Atmospheric pressure pushed the piston down. It didn't rely on high-pressure steam. It relied on atmospheric pressure after condensation. But that process wasted enormous heat. Rough estimates suggest about 78% of heat was lost in the injection water, and another approximately 22% in repeatedly heating and cooling the cylinder. Efficiency hovered around roughly 0.5 to 1%. Still, it worked. For the first time, heat could be turned into motion at scale. No horses, no rivers, no wind, just fire, water, and pressure. A new kind of power was born. Newcomen's engine spreads slowly. Mine owners install it because it saves money and keeps operations alive. That's it. No grand vision. No global ambition. Just practicality. But something important happens. Engineers begin observing, tinkering, improving, questioning. Why does it waste so much heat? Why is it so slow? Why can't it do more than pump? And then, decades later, someone sees the flaw and the opportunity. In 1764 to 1765, at the University of Glasgow, a Scottish instrument maker named James Watt repairs a model of a Newcomen engine. He notices something most people miss. Every cycle, the machine heats and cools the same chamber, again and again. It's wasting enormous energy. Watt proposes a radical idea: separate the condensation process from the main cylinder. A separate condenser. The cylinder stays hot. Condensation happens elsewhere. In 1769, he patents the design. It changes everything. Efficiency jumps dramatically, roughly 2 to 4% in many applications. That sounds small, but it's transformative. Now the engine becomes cheaper to run, more reliable, more adaptable, and no longer limited to mines. Once steam engines improve, something incredible happens. Power becomes portable. Factories no longer need rivers. Machines no longer depend on muscle or wind. Industry can move anywhere. Textile mills expand across places like Lancashire. Manufacturing accelerates. Urban centers grow. Steam doesn't just pump water anymore. It spins wheels, drives pistons, moves machines, and quietly, it begins reorganizing the entire economy. Then comes the next leap. If steam can power machines, can it move vehicles? Yes. In 1804, Richard Trevithick demonstrates the first viable steam locomotive running on rails. This happens after decades of stationary engines like Watt's. And once locomotives appear, the world compresses. Railways expand. Goods travel faster. People move farther. Soon, steam-powered ships cross oceans without relying on wind. Trade accelerates. Cities connect. Markets merge. Globalization takes its first mechanical breath. All from a machine originally built to pump water. Steam engines don't just transform industry, they transform science. Engineers begin asking new questions. What is heat? What is energy? Why do engines lose efficiency? In 1824, Sadi Carnot analyzes steam engine efficiency and proposes the concept of an ideal heat engine, a foundation of thermodynamics. In the 1840s, James Prescott Joule demonstrates the relationship between heat and mechanical work, leading to the law of energy conservation. In the 1850s, Rudolf Clausius formalizes the concept of entropy. In trying to improve a machine, humanity discovers fundamental laws of the universe. Steam power reshapes daily life. Factories replace workshops. Mass production replaces handmade goods. Urban populations explode. Time itself changes. Railways require synchronized schedules. In Britain, standardized railway time begins spreading in the 1840s-1850s. In the United States, nationwide time zones formalize in 1883. The rhythm of human life becomes mechanical. Work shifts, timetables, industrial pacing. The modern world begins to take shape. Here's something we often forget. James Watt didn't build this revolution alone. His partnership with Matthew Boulton allowed steam engines to be produced at scale. Engineering met manufacturing. Ideas met capital. Innovation met infrastructure. This wasn't one genius moment. It was a network of inventors, investors, mechanics, miners, and factory owners. A collective engine. The steam engine reveals something deeper about history. Game-changing innovations rarely begin as grand visions. They begin as solutions to narrow problems. Fix water in a mine, and you invent industrial power. Improve efficiency, and you trigger global manufacturing. Move machines, and you transform transportation. Study heat loss, and you create modern physics. The modern world didn't arrive through one invention. It arrived through a chain reaction. And the first domino was practical. Today, we're searching for the next revolution: AI, biotech, energy, automation. But history tells us something surprising. The biggest transformations don't start as revolutions. They start as tools solving specific problems. Steam engines solved flooded mines. Batteries solve energy storage. AI solves information overload. Small solutions, massive ripple effects. The steam engine didn't just power machines. It powered a new era of humanity. If one machine built for flooded mines could launch the modern world, what tools today are quietly preparing the next transformation?
Glad you stayed to the end. That means your curiosity's alive and kicking. If you're into this vibe, like, subscribe, and tap the bell for more mind-bending moments. And don't leave yet. Pick the next video and keep the spark going. See you soon.